Hello, we are Team Deep Green. My name is Nathan. I am joined with Luke, Ethan, Philemon, and Jawad, and we are being sponsored by Satellite.
Our sponsor, Satellite, has commissioned us to help keep cyclists safe by evaluating the environment around the cyclist for potential dangers. Specifically, we are to create a program capable of determining if a biker is on a trail and what the properties of the trail are. To help us achieve this goal, Satellite has provided us a device called the Bean, which is capable of taking video from the back of a bicycle and running machine learning models locally. Our solution is a convolutional neural network that takes in image data from the back of the bike and determines if the biker is on the trail or off the trail. But before we could work on that, we need to be able to gather and label trail data. LabelMe is a tool for labeling images. As it was released under the GNU General Public License, we forked the code and modified it for our own use. Specifically, we implemented changes to enable importing of video files, breaking those files into frames, as well as easier navigation of the frames themselves. This is what we use for labeling our data. Creating masks to label where the trails were. We could also use the tool to label other things, such as the water tower as shown. However, our primary goal was identification of trails. To gather the trail data, we simply rode bikes while collecting data with the Bean.
Our job then is to try to analyze data of these images, and more specifically trails, where trails stop and end, and how to segment the image properly. The technology we're using consists of a Jetson Nano GPU for model training and processing. It has a camera and 2 infrared cameras. If you look at the green hardware piece that looks kind of like a face, you'll see that the eyes are 2 infrared cameras and the nose is a visible spectrum camera. Is gathering data for this set. Because we are using a deep learning model, we needed to gather quite a large sum of data. We did this by strapping the Bean to the back of the bicycle and riding around on different trails to collect data. In total, we have more than 500,000 samples to train our model on.
So the model that we decided to go with is based on this paper. It's called FastSCNN, Fast Semantic Segmentation Network, and it's made for embedded devices with low memory, which is the device that we're using, we're employing. Now this isn't state-of-the-art, but it's a very modern design for this type of model. It employs novel techniques like pyramid pooling. And in the code, the model that we were able to reproduce using this paper has nearly 2 million parameters, 1,798,000 parameters, which include convolution layers, upsampling, and sophisticated techniques like pyramid pooling and bottlenecking. The design of this model, as in this graph right here, can show you all the different layers. And after many epochs and training, leaving this running overnight, we were able to produce results that are very interesting. Here is a sample image of something that's unlabeled. This image was not labeled in the label program. And this is what the model identified as a trail. So you can see that it does a pretty good job of picking out where the trail is inside the image. This being the dirt trail, and this being the image. Like in this image, the model is able to pick out a completely different trail type. It's not dirt anymore. It's a sidewalk or a path, pavement. And this model, you can see, was able to distinguish between the trash can and this image right here. It's able to understand that these pixels, whatever color these are not the trail. And here you can see that the leaves, which is very hard for a model like this to determine what are leaves and what are not trail leaves, it makes this middle mistake here and samples something over here as being the trail. But for the most part, it does a pretty good job of being able to find the trail in the image. And here, like in this image, anywhere where there's a contour, a very well-defined boundary between areas of the trail and not trail, it does a pretty good job of finding the trail or the path. Here, where it's not so easy to find, it gets cut off by this pillar thing here. That's not included, but for the most part, whatever it's looking at, it seems like the model is able to do a pretty good job of identifying what's the trail and what's not the trail.